Okay, guys, let's continue my lecture. As you can see here, we can classify enzyme. This is important, this is important, this is important. You should remember these 6 class of enzyme. We have 6 class of enzyme in our body. The first one is oxidoreductase. Oxidoreductase, which means this enzyme can oxide a molecule and reduce another one. Oxide a molecule can reduce another one. Oxidoreductase. Both reactions will perform with this enzyme. You can see some examples for this enzyme. Dehydrogenase, which means that this enzyme remove hydrogen from molecules. Dehydrogenase. Oxidase, this enzyme oxide some molecules or transfer oxygen to another molecule. Peroxidase, reductase, monooxygenase, and so on, etc. Second class is transferase. Transferases transfer a functional group, a group in a molecule to another one. Very easy, very simple. Transfer a group in a molecule to another one. For example, C1 transferase, glycosyl transferase, a very important enzyme in our and which involving producing bile salts in our GI system, intestinal system. Bile salt, safrawi, GI system. Bile salts, bile salts or the second one, the third one is hydrolases. Remember the first, our lecture about water and butter. The last slide of water was about enzymatic reaction of water. I told you that water can cut molecules. Like makas. So such enzyme apply water to cut molecules. This enzyme are named as hydrolases. This is the example. Esterases, glycosidases, peptidases, and so on. The fourth one, oleases or synthases, liases. This type of enzyme can link two molecules with each other without energy. Can attach two molecules with each other without energy. This is the example. C liases, CO liases, and etc. Fifth class, isomerases, which change an isomer to another one. For example, epimerases. Do you remember epimers? Yes. For example, glucose and galactose. Glucose, epimers are a type of diastromers. Some type of. So, glucose can change to galactose with epimerases. With the epimer. Cis-trans isomerase. Intramolecular transferases are some type of isomers. And the last one are ligases or synthetases. Look at the difference between synthetases synthesis. We have an extra T in this enzyme. T. As you can see here, also this type of enzyme can link, can join, can attach two molecules, but with energy, with applied energy. So the point is that the difference between ligases and liases or synthesis is using energy for the reaction of synthesis, but without using energy in forte. Do you understand? Another point. Look at the flashes, arrows. Look at the arrows. As you can see, we have both forward and reverse. Forward and which means enzymes can perform the reverse reaction. And this is completely depend what we need in our what? In our cell. We need B or we need A. Okay, you understand? Yes. So if we need A, the enzyme catalyze the reverse reaction, not forward.
Can you explain the last one?
Just last one, this one. Ligases or synthesases. We have a T, extra T for this enzyme. This type of enzyme can link, can join two molecules with each other, but with applying energy, using energy. استخدام with using energy. So this is the difference between type enzyme class 6 with enzyme class 4.
Doctor, in this classification, what we will remember? The example or
the classification of enzyme, for example, you should know what is the fourth class of enzyme and what they do. Okay. The fourth class of liases, and they do this. And this is the example.
We have to remember all example or
yes, this is a very important slide for you. Another point: which type of enzyme can produce ATP for us?
the
Last one. In the reverse reaction, you can have ATP. Okay. So the last type of enzyme, the last class of enzyme can produce. Okay. What is the location for performing enzyme reaction? This is an enzyme, but just a small location, a small place, very small place among enzyme structure can do enzymatic reaction. We name this location, this place as an active site. Active site. فعال. مكان فعال. Okay. So this is a very small place. We named it as active site in enzyme that perform enzymatic reaction. Furthermore, this place divided to two extra places, the red one and the blue one. Active site can divide it to two places, this blue and red. This is binding site which bind to substrate bind and orientate substrate, and catalytic site, the red place, catalytic site, which reduce chemical activation energy, which is the enzymatic reaction place. So, active site can divide it to two places, binding site and catalytic site. So, if I ask you what is the place for enzymatic reaction, active site and catalytic site, do you understand something?
So the binding site, what is it?
Sorry?
The function or the binding site?
As you can see here, for example, let me give you an example. Do you see the cutter which used in factories, big cutters in factories? For example, those that cut metals, you put metal inside them, but just the cutter of this metal. This is a type of cutter. You put this metal inside cutter, but you have just a blade here. The blade is located here. This is the catalytic side. This is the binding side, and totally this is the active side. Okay. Okay, I told you. Very important slide. We have two hypotheses. For enzymatic reaction. If in Iran, students learn before they come to university that enzyme and substrate are complement each other. They are complement, like key and right. Like lock and key, this one. Lock and key. They are complement each other. Completely like antibodies and antigens. Like lock and key. Another hypothesis is that enzymes are complement to transition state, not to substrate. So we have two hypotheses, two farziyah. Okay. The first one is enzymes are complement to substrate, to reactant. The next one is enzymes are not complement to substrate. They are complement to transition state shape. Transition. In your opinion, what do you think? Which of these hypotheses is true?
So the first one.
Why or why not? This is the point. Let me explain. I think it could be difficult for you. This is a reaction without enzyme. For such reaction, you need too many times to be performed. You have a metal stick, you want to break it into two parts. You need some time, you need energy, activation energy, and finally you have products. With enzyme, we have two hypotheses. The first one is enzyme and substrate are complement to each other, mukammal. Okay, Muhammad? Yeah, Muhammad. But the next one is enzyme is complement mukammal to transition state. So, as you can see, when the enzyme is complement to substrate. When enzyme link to substrate, the energy of enzyme and substrate is lower than product. In this hypothesis, when enzyme join to substrate, the energy will decrease lower than product. So, such reaction do not perform. However, in the next hypothesis, which enzyme is complement to transition state, the energy will decrease, but not lower than product. So, the point is, the second is true. Therefore, enzymes are complement to the transition state. So, induced fit model. Induced fit model. I don't know model. What is the model in Arabic? Model. Model. Induced fit means إلقاء يعني بيكينج ورك هو نزل
موديل تسوي نفس الشيء.
induced means يعني بيكينج ورك هو
افتراض.
So the point is that enzyme will follow induced fit model for their reaction. So enzymes are complement to transition state. Okay guys? Did you another?
Doctor,
Yes.
when enzyme completely
Be silent. Be silent.
هدوء هدوء هدوء
خذ الصوت خذ الصوت.
هذا اسكت. I don't know if it is a bad word or not. اسكت is a bad word in Arabic. Uskud is a bad word or not? Bad word. What should I say?
حافظوا على الهدوء. حافظوا على الهدوء.
هدوء هدوء هدوء
خلي القشع. هدوء 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 هدوء.
Doctor, when enzymes
Guys, please.
when enzymes completely substrate, we don't have energy.
No, when enzyme complement to such like that.
Okay.
When enzyme complement to substrate, the energy is decreased
Decreased, no.
lower than energy of product.
Products.
Okay, so they are stable. They don't want to proceed to product. They are stable. They are stable.
استقر.
استقر. Okay, they don't want to proceed to product. They don't need to be proceed. Okay. Very good. So, look at the board and well, as I said, all process in our body, all thing in our body controlled by enzymes. So, if you can control enzyme, you can control your body. How we can control enzyme? With drugs. For example, you use NSAIDs like naproxen, like profen, and other drugs as anti-pain, as painkillers. When you have headache, you use naproxen, for example. Okay, to cure your headache. علاج your headache. Okay, so we can use drugs to control enzyme and control our body, our patient body. So this is the important clinical importance of enzyme in our body. For example, see the animation. Look at the animation. In living organism, enzyme catalyze reaction, shuttle intermediate component along the directed pathway and provide control our biological process. Whether animal, plant, bacteria, or virus, enzymes are necessary for life. Enzymes are also of extreme medicinal interest for most of blood described. First, what is the kinetic of enzyme? Enzymes are completely like vehicles, cars, machines. Okay? You have a car. You can press pedals and accelerate the car speed. Your car needs oxygen and fuel, oil for burning and produce energy for this car. Okay? Okay. When you press your pedal, the speed of car will increase. But any car, each car has a limitation. Okay? Each car has a limitation for the speed. If you press pedal in this point, you cannot have more speed because this is the limit of your car. Okay? Such thing will happen for enzyme. When you give your enzyme substrate, enzyme accelerate the reaction. When you give more substrate, enzyme accelerate more. However, we have also some limitation for enzyme. We have a limitation for the speed. You understand? Just like how you have a speed limitation for enzyme. So, if you can see the graph, you have such graph. Please be silent. Guys, you have such graphs. This graph named as Michaelis Menten curve. Michaelis Menten curve. So the point is, what is the explanation for enzyme kinetic? What is the explanation for enzyme kinetic? The explanation is if we have more substrate, if we give more substrate to enzyme has more speed, but the speed will increase to a level. This level is a limitation for enzyme speed, like vehicle, like cars. This is the explanation of Michaelis-Menten curve. Michaelis-Menten curve. We have a formula for this explanation. We have a formula. The formula of Michaelis-Menten curve is this. V0 is equal to V max multiplied concentration of S means substrate, divided to Km sum to S or substrate. What is Km? Km or constant, K means constant, is a concentration of the substrate at which the reaction rate or speed is half the maximum velocity V max. Km is the constant of the Michaelis-Menten. So M is abbreviation for Michaelis-Menten and K is abbreviation for constant. Look at here. This is the substrate arrow and this is the V arrow. V or velocity of speed, velocity or speed, and this is substrate concentration. This is the maximum velocity or maximum speed of enzyme. This is the substrate need for achieve this speed. This is the point of half of V max. Half of V max. 1 Vmax. Okay? As you can see here, this point needs Km. So Km is the concentration of substrate needs to gain to this point. Half of V. Half of Vmax. Okay? You understand? Do you need further explanation?
Yes.
Again. This is the Vmax. This is the Vmax or maximum speed of enzyme. حد أكثر. Okay? This is the
نص السؤال
نصف.
نصف yes.
This is the NISP or half of Vmax. Okay? As you can see, if you look at this point, the concentration of substrate which needs to produce half of Vmax is named as Km. Km. A question for you. A question for you. You have the formula. Please reply and solve this question. If the concentration of Km is much higher than S, what would be the formula? Please solve this question. If the Km is more higher than S, what happened to the formula? Please write. You wish.
What happened?
Right, and solve the formula. You have the formula, and you have such condition. The condition is Km is much higher than this. Then it.
هو يقول
Yeah.
هو ذاك صحنا ما السؤال
What happened to the formula? You have the formula. This is the Michaelis-Menten formula. That one. Okay. The condition is Km is higher than S. What happened to the formula? What happened? This formula. Okay.
Doctor, I think the thermolysis decreased.
I don't know. Please write and give me your point. No. Okay. Hassan, can you come and solve the question? No. It's like football. No problem. Sorry.
لو كنت عندك جوز قال لي حلها بالوضع.
Okay, let me solve this question and I will give you another question. Okay, when Km is higher than, much higher than this, for example, the Km level is, for example, 1, but, and the unit is millimolar, mm, millimolar. And the substrate that we have in the reaction is, for example, 1 multiplied 10 power, for example, minus 12. As you can see here, this level is too low. Okay, so let me.
Vmax?
Wait a minute, please. When Km is higher than S, so this S could be deleted from the reaction. This is much higher than this level. This concentration is higher than, so you can dismiss this level. You can do not consider this level. Okay, so I can delete S from the formula. What about the upper level? Can you delete S from the upper one?
No.
Why? Because any number can have an effect on the multiplication. Okay? We don't have such effect on sum or jump. But any number can affect on multiplication or you understand?
Yes.
Okay. So when the Km is higher than S, the formula is B max. B0 is equal to B max. Yes. Per Km. Okay. Another question, please. Do this. What would happen when Km is much lower than S? Yes, this one. Dalal, other ladies, please participate in class. Not just talk to each other. I don't know. Right, and give me your solution. No.
Do you bet? أعلى الانسحابي.
When we have such condition,
تعال دورك تسوي ما تقدر تجاوب قول لي تعال في 0 يساوي كم ماكس؟
I will mark S. I create, this is S.
Doctor, when this is very low, we can eliminate it. So
I think if you could talk with
بالعربي
Doctor,
I will go talk in English.
Very
Doctor, this is very low, so we can eliminate it, and we can eliminate this.
Very
It
good.
will be V max.
Very good.
هو جمع ليس انحدر.
بما ان هذا قليل
انحدر. الأس تروح إلى الأس يبقى بس V
هذا
max
لما
يساوي.
يحسب يبقى V صفر يساوي V max.
يعني
هذا قيمة المشكلة منها
So, do you understand that? Okay. So, this is very important because we use this formula in clinical laboratories. We have too many enzymes in our body that can apply for diagnosis of diseases. For example, we have ALT, AST in our liver and can use for
ما أدري.
liver
أنا مثل حلت
for
بالبداية.
liver
خليتها ببالي إيه.
We use this
سالفة
formula
بسيطة.
to find what is the level of enzyme in our body, in our blood. You understand us? So, we give enzymes substrate and find out the velocity of enzyme. Okay? So, in clinic, in laboratories, we give enzyme, we get them substrate, too many substrates. So, at the first point, V0, we have the real mass. So, if we get the enzyme reaction, too many substrate, at the first step, we have Remax. At the first point, we have Remax. This is the strategy that we use in clinical laboratories. two other scientists, Weaver and Ware, change the equation as this equation. They just divide the mechanics method equation by one. They reverse the equation. They just reverse the equation. So, no, they have a linear curve. They don't have another. They change the curve to a linear platform. We have three important layers in this platform. The first one is the connection in Arabic taqato. The first one is this point, taqato, between this curve, this slope, and y-axis, y-axis. The next one is taqato between x-axis and the line. We name this point very important. Please write this. Very. We name this point as 1 divided V max. We name this point as minus 1 divided A minus 1 divided V max minus 1 divided Kn. Too many questions will take you about this slide. There are too many questions about this slide. Well, this is our last slide for today. Ahmed said that you want to change your exam date to Sunday, no problem, we do this. So our exam will be on Sunday, and I will see you tomorrow at 8, okay? Okay. Tomorrow,